You are welcome to Eagle's Concept Learning Room. In this video, we're going to walk you through Science Paper 2, 2018. So this paper is composed of 3 sections, and please remember that Science Paper 2, 5124-2 is composed of chemistry. So Section A has got 20 multiple choice questions. Section B has got about 9 short answer questions. And section C has got 3 questions, of which you are only to answer 2. So let's go through section by section. Section A, you are supposed to answer, to give your answers on this provided grid. For example, the answer for question number 1 is D. So you have to put your cross nicely like this. This is how you answer. Now, I'm going to advise, if you are not sure about the answer, you better mark it using a pencil, which can easily be rubbed off. But in as much as you put it in a pencil, please remember to always pass through with a pen, because here it's not like grade 7 where we answer using pencils, but a pen is what is advisable. All right. So question 1 reads, which one of the following sublimes when strongly heated? Now, the keyword in this question was sublimes. So to sublime is to directly change from solid, to change state from solid to gas. Okay, so sublimation is the direct change of state from a solid to a gas without passing through the liquid phase, and this only happens when it is strongly heated. Examples of substances include iodine crystals. So the correct answer for number 1 was iodine crystals. Question 2. Identify the measuring apparatus shown in the diagram below. So in the diagram below, we have what is known as a conical flask. Now, a conical flask is in the family of apparatus called volumetric flasks. So there are 3 in this family. We've got the conical flask. We also have what we call the round bottomed flask. Like the name, it looks round like that. Then we also have what we call the flat bottomed flask, which will definitely look something like this. So let me just draw it a little bit nicer so that we are not guessing. Okay, so this one will have a shape, it's flat, like its name suggests. So it will look something like this. Okay, it will look something like this. So these are the 3 types of the volumetric flasks that we have. This one is called a conical flask, this one is called a round bottomed flask, and this one is called a flat bottomed flask. So together they are known as volumetric flasks, and their collective function, or rather general function, is preparation of standard solutions. So standard solutions are solutions whose concentrations are known. Okay, so it is just based on you recognizing them by their shape, and you can easily recognize that this one is a conical what? Flask. Question 3. What term is given to atoms of the same element with the same atomic number but different mass numbers? So here you can recognize to say, here this is the definition of an isotope. So an isotope is defined as an atom of the same element, so the same element having the same atomic number, meaning same number of protons, but different what? Number of neutrons or mass numbers. So we can give an example of hydrogen. So hydrogen has got 3 isotopes. We've got what we call hydrogen 1, which has got a proton number of 1 and a mass number of 1. We've got hydrogen 2, also known as deuterium, which has got a mass number of 2 and a proton number of 1. And we've got hydrogen 3, which is tritium, which has got a mass number of 3 and a proton number of 1. So you can see same number of protons but different number of mass numbers or neutrons. So our best answer here was simply isotopes. So number 3, our answer was C. Let's go to number 4. Metallic bonding is the loss and gain of electrons between metallic and non-metallic atoms. No, this one is just the definition of what ionic compounds are. Okay, so we go to B. B says sharing of electrons between non-metallic atoms. So this one is covalent or molecular bonding. Then force of attraction between valence electrons and the metal ions. This is what metallic bonding is. So for example, I can draw something like this. This is a box. Then in this box, I'm going to show, for example, for sodium, so it is going to be Na plus. I write a lot of Na plus, and then around it, I put the electrons like that. So Na plus, I put the electrons like that. So that is just an example. Okay, we go to question 5. Which which one of the following oxides can be neutralized by both aqueous sodium hydroxide and sulfuric acid? So we have something that has properties of both acids and bases here. And when we look at the types of oxides that we have got various types of oxides. So for a start, we've got what we call the acidic oxides. These are the oxides of nonmetals, for example, carbon dioxide. Then we've got the basic oxides. These are the oxides of what? Metals, for example, calcium oxide, magnesium oxide, etc., etc. Then we also have the neutral oxides. So neutral oxides, we have these are mainly things like water. Okay, they are not reactive. So we also have lastly what we call the amphoteric oxides. Now these amphoteric oxides, these are the oxides that are able to react with both acids and bases. So examples of amphoteric oxides, we are talking about the oxides of lead, the oxides of zinc, and the oxides of aluminium. So those are the three common ones. So let's see if we have any of those on here on the list provided. So D qualifies because we have lead oxide. Okay. Question 6. Study the reaction scheme below. Black solid A reacts with dilute sulfuric acid to produce light blue solution. Now, light blue solution, this one always in chemistry, it indicates the presence of copper 2 plus ion. Okay, so this light blue solution, they added hydrochloric sodium hydroxide followed by excess of it, then it gave us a light blue PPT. So here we have just confirmed again that we have copper 2 plus ions. Okay, then when you check here, they are saying this is a black solid which was able to give a light blue solution. Now, a solution, this one can be a salt. Now, a salt, it also produces water. So this is a neutralization reaction that we are talking about. So basically, this is a base. Okay, so a base, which is a solid, it has to be an oxide. So definitely here, we are talking about copper 2 oxide. So we have analyzed that. So copper 2 oxide will give us copper 2. So this is copper 2 oxide. So this copper 2 oxide will give us this one and that one. Okay. So let's look at what we have. So this solution, we can easily identify it. So black solid, our black solid here, the answer is actually A. We have copper 2 oxide and the water. Okay, so we continue. This one reads 7.8 grams of pure zinc metal was reacted with 100 centimeters cubic of 2.0 mole per decimeter cubic hydrochloric acid. Which one of the two substances was a limiting reagent? Reactant in excess and the correct formula for products. So now the first thing that we have to remember here is, remember, they say metal plus an acid. Okay, so metal plus an acid will always produce a salt and hydrogen gas. So these are the products all the time. So we just try to fill in the metal that we have here is zinc. Okay, so zinc plus the acid that we have is simply the HCl. So we have the HCl. Okay, then this one should be able to give us, so you always get the metal and the last part. So this one will give us zinc chloride like this. Okay, so zinc chloride, then plus our hydrogen gas. Always ensure to write the state symbols as you write in your equations. So this is solid aqueous gas. You write that. Okay, then you also balance. since you have 1 here, 1 there, 1, 2 there, it means that you can add a 2 here and the equation is balanced. Okay, now what they want us to find is a limiting reagent. Now, when you are reacting, first of all, from the equation, there are certain things that we know. We can go to formula for products. So this one here, it's correlating with the products. Okay, this one, no, the water makes it wrong. This one, they forgot it too. So this is wrong. This is also wrong. And this is also wrong because of the two formulas here. So this formula is accepting. So without further ado, this is the only thing that has accepted, making A our best answer. The other method of finding this one, in this case, it is the one for calculating, because limiting reagent is a reagent that is in short supply by mole ratio. So you can easily say number of moles of zinc, okay, divided by 1, which is the coefficient there, is equals to number of moles of HCl, okay, so number of moles of HCl over 2. Then you can find the number of moles of HCl by using the formula number of moles is equals to mass over molar mass. So the molar mass you get on the periodic table. Then for this one, you can use, because what you've been given is concentration and what you've been given is volume and concentration. So you can use number of moles is equals to CV. And you can use this one also. It can help you, but in this instance, all you needed was a reaction equation so that you determine the product, and the answer will automatically come out as A. Okay. Question 8 reads, how many moles of oxygen gas would occupy a volume of 1200 centimeters cubic at room temperature and pressure? Now, at RTP, there is a simple rule. 1 mole, okay, 1 mole of any gas at RTP occupies a volume of about 24 decimeter cubic. So 24 decimeter cubic. Okay. Now, how many moles will actually be equivalent to the volume that would be given? So now, before you can use this volume, ensure that you convert it to decimeter cubic by dividing by what? 1,000. So you divide by 1,000. Why? Because we know that 1,000 centimeter cubic is equivalent to 1 decimeter cubic. So divide this by 1,000, and you are going to have something like a 1.2. So you cross multiply there, you are going to have the 24x being equal to 1.2. So you divide this one by 24. Also this side you divide by 24. So you do that. This is chemistry. You can make use of a calculator. So you find that x will be equal to, so you punch on your calculator, and x will be 0.05 moles. So please, as we are doing this, go through with your calculator as well. Don't just be watching as if you are watching a sermon. So make sure that you also practice through with a calculator. So 0.05 moles. Okay, so 0.05 moles is what we have found. And you check on the answers. Do we have 0.05 moles? Yes, we do. And question 8, the answer is A. We proceed. Elena carried out 4 experiments on rates of chemical reactions. The result of the experiments were recorded on a graph as shown below. So when you look at this graph, you can tell that this one started very fast, okay, followed by 3, 2, then 1 was the least. Okay, which reaction shows the fastest reaction rate? So this one was clearly D, okay? It was clearly D, so you can check the one which has a steep here, it shows fastest, because if you can make some lines, for example, you make any lines like this, okay, you can also make maybe a line like this one, so you can tell to say here the same amount of the same amount of product were produced here and there and also somewhere there. But one thing that is different is if, let's take for instance, this is time number 1, then this is time number maybe 2 seconds, then this one will be 3 seconds. So you can say, we also say this is 5 centimeters cubic. Now for reaction number 1, 5 centimeters cubic was produced in 1 second. Then for reaction number 2, 5 centimeters cubic was produced in 2 seconds. Then for this one, in 3 seconds. So you can tell that rate is always product over time. So this one was very fast. That is one way you can actually determine the rates using a graph. Okay, question 10. Element W has high boiling and melting point. It forms two oxides. So it forms WO and W2O3. This element is, now you can see the valence of W in here and the valence here is different. So the valence here is what? Is 2, but the valence here is 3. Now, when you look at the periodic table, all the way from the alkaline earth metals, transition elements, the halogens, and all the way up to the noble gases, it is only transition elements that have the ability to form to have different valences. So the correct answer is transition element. So this element is what? Is a transition, because transition elements, they've got variable what? Valences. Okay, so let's read question 11. So question 11 reads, rubidium is in group 1 of the periodic table. Which element, okay, so which element is in the same period with rubidium but found in group 4? So now, when you roughly look at the periodic table, I think, let me just draw something roughly. So our periodic table will look something like this. Okay, to look something like this, just the top part. So we have group 1, group 2, then 3, 4, 5, 6, 7, and 8. So going down here like this, going down like that, this is a group. Okay, then going across like this is a period. So now period 1 starts from where there is hydrogen there and helium on the other side. That is period 1. So period 2, when you check on your periodic table, period 2, that is where there is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, so always remember that. Now the question here is saying rubidium is in group 1 of the periodic table. Which element is in the same period with rubidium? So when you check where there is rubidium there, we start counting, it to be 1, 2, 3, 4, 5. So rubidium is in period 5, and then they are saying which element is in the same period with the rubidium but found in group what? In group 5. So you hold rubidium, you keep on going until you go to group what? Group 5, and this one will be found to be SB. This is SB, and the name is antimony. So you find your answer as B. So always remember, the periodic table is a very important tool if you are to pass chemistry. So, and it is given usually at the end of every question paper. There is a periodic table that is provided. Question 12. Metals are able to conduct electricity because, so let me just give a comment here. Now, most metals are solids at RTP. So if metals are solids at RTP, we expect that they have closely packed particles like in a what? In a solid. So now, these metals are they are called good conductors of heat because of the closely packed particles. That is another reason. Now, metals are also good conductors of electricity because they have got delocalized electrons. So the word delocalized simply means mobile electrons. So those are two different things. The reason why they are good conductors of heat and the reason why they are good conductors of electricity, these are two very different reasons. So always let's remember that. I'm emphasizing they are good conductors of electricity because they've got delocalized electrons, which means mobile electrons. The electrons are able to move about, and they are good conductors of heat because of their closely packedness, just like in a solid. Okay, so we can pick our answer from here. They have delocalized electrons, so automatically that is our answer. Okay, now their particles are closely packed. No, this is an explanation for the reason why they are good conductors of heat. Okay, they form ionic compounds? No, they are ductile. This is another reason also. So we'll look at these things as we meet them. Number 13, Elena set up the following experiment using iron nails. Okay, then here we have tap water, we have the iron nails. Okay, here we have oil, boiled water, iron nails, and here we have iron nails, cotton, and calcium oxide. Okay, so these are in which test tube will the nails rust? Now let's look at the three conditions that are necessary for rusting of what? Of iron. So rusting of iron requires air, water, and an electrolyte. So we are talking about here air, okay, water, and what we are calling an electrolyte. Okay. Now, when you look at that one, definitely here you check. Let's check this one, test tube X. So in test tube X, we have got tap water and we have got the iron what? The iron nails. Okay. So here the best answer is actually C. Why? Because in here we have some air that is coming in. Then we've got the water, the tap water here, and we have a strong electrolyte as well. Now here in test tube Z, why can't it happen? Because here we have the cotton wool and there is no water here. So this one cannot happen because there is no water. Also here, the oil here is to prevent the air from reaching in the water here. So there is no air, meaning rusting cannot happen. But here we have access, air is coming in, then we've got the tap water at least. And in the water here, it's possible there is an electrolyte. So X is the only one which is expected that rusting can take place. Okay, A14, which gases make up more than 90% of dry air? So now, the composition of air, when you look at it, is 79% to 80% oxygen. Then you are going to talk about 79% nitrogen. So this is the nitrogen. Then 21% oxygen. That is the composition. Then we have about 0.03 carbon dioxide and the other gases also. So when you just add these two, we are going to have a 0 there, then 7, okay, that is 9 there. And so these two here, they will give you the percentage. So I'm emphasizing, let us know the percentage composition of air. So we've got 79% nitrogen, 21% oxygen, 0.03 carbon dioxide. Then we also have some percentage of water vapor and the noble gases. So those are in very small percentages. So once you know that, you can easily combine any two. So which gases make up more than 90% of dry air? It is these ones here. So the best answer here was simply nitrogen and oxygen. So the answer for 14 was actually D. Okay, we go to question 15. In a particular laboratory, the following elements were in stock: zinc, copper, sodium, carbon, and iron. Okay, so the arrangement of the elements in order of their decreasing reactivity is, so this one now I'll emphasize, I'll just take you to something called the reactivity series. So this reactivity series here, it has to be memorized at all times. So here we mean that potassium is the most reactive, then gold is the least reactive. So this reactivity series here, they were testing how fast metals react towards water and towards acid, and this is the order in which they gave. Okay, so some here, they do not even react them with acids in real life because they are explosive and they can cause accidents in the lab. So some metals, when you're handling them, we use water. Others we use acids, like these that are below hydrogens here. Below hydrogen, we can use acid, but these things like the potassium, sodium, we can't use the acids because their reactions can be explosive. Okay, so please let's bear this in mind and see which ones they are. So here, the metals that we've been given zinc, copper, sodium, carbon. So we've been given zinc, copper, sodium, carbon, and iron. So, and iron, which is Fe. So we have to put them in what? In order. Okay. So we have to put them in what? in order. So in order of what? We are saying in order of decreasing reactivity, decreasing. So we are starting from the highest to the lowest. So from here, we know that this one is sodium Na here. So definitely sodium is the most reactive here when you check. So sodium, so this one will be Na, okay? From sodium, it has to go to, okay? So we have our sodium here, then we've got our carbon. Where is carbon in here? Do we have carbon somewhere? Okay, let's ignore carbon for now. We go to which one is more reactive between zinc and copper. So zinc is more reactive. So we go to zinc. Then zinc, we go to iron. So zinc ion, then copper. So zinc ion, then copper. Okay, so zinc ion, then copper. So this is the decreasing. Now, where we place carbon, it will be automatic from the choices that will be given, because carbon is apparently not part of the what, not part of our reactivity series here. Okay, and it is not a metal. This one actually, it is somewhat non-metal. Okay, let's see about that. So we are saying sodium, zinc, iron. So sodium, zinc, iron, copper. Sodium, zinc, iron, copper. So let's check. We start with this one: sodium, carbon, zinc, iron, copper. So the answer is straightforward here. It is AC. It is making much more sense. Now here we know I have to start with sodium. Now this one is sodium, iron, carbon, zinc, copper. Okay. So now here, this carbon here cannot be more reactive than zinc. That is just the way it is. So the best answer here was C. And I'm emphasizing, let us know the reactivity series. Okay, let's go to question 16. The diagram below shows the setup used to detect the presence of carbon dioxide in polluted air. So polluted air goes in, then substance X here. The only thing that we use is lime water, and lime water is actually calcium hydroxide. So this X here is automatically calcium what? Hydroxide. This is what we use when testing for the presence of carbon dioxide, because it turns milky. So calcium hydroxide is known as lime water. So the lime water turns milky. Go to question 17. The diagram below shows the fractional distillation of crude oil. So the diagram below shows the fractional distillation of what? Crude oil. So here we have the fractionating column, we have crude oil, and that is how it works. So let me just explain something about this fractionating column. So those that have got high boiling points and high densities, they are collected at the bottom. Then those that are lighter and low boiling point, they are collected at the top. So we've got the petroleums there, then we've got the bitumen at the bottom there. So which explanation below is a correct reason for fraction H to be collected below fraction G? So fraction H, it means it has got a higher boiling point and also high weight. Okay, so it is higher. That's why it is collected below fraction G. So average molecular mass of H, okay, greater than G. Okay, so we'll settle for what? For greater than G, according to what we've written there. Then boiling point of H, it is also higher than G. So automatically, this is the truth. Okay, so that explanation should be able to get you through. Question 18. The substance that conforms to a homologous series with a general formula CnH2n is, now this general formula, we have to keep them off by heart. So this general formula here, we are saying this one is for what we call the alkenes with an E, alkenes. Okay, that is the general formula there. Then we also have the CnH2n plus 2. This one is for alkenes. Then we have others like CnH2n plus 1, then OH. This one is for the alcohols. Then we've got others like for acids, which is CnH2n, okay, plus then we have just COOH. So this one is for carboxylic what acids. Okay, so let's be aware of these various molecular general formulas. Okay, so uh, here let's now choose the correct answer, having that little bit of knowledge. So this is alkenes, we know. Then let's look at, okay, this is an acid. So butene is definitely an alkane. Butane no. Okay, so the best answer here was butene, because that is the only one which is in this family of alkenes. All right, so question 18, the answer is B. Let's go to question 19. Which one of these organic compounds will decolorize bromine vapor? Now, bromine vapor can only be decolorized by alkenes. So alkenes are unsaturated hydrocarbons. So unsaturated hydrocarbons are the ones that are able to react with bromine, okay, to decolorize it from its reddish brown color to colorless. So on the options here, we have to look for an alkene. So the fact that this one has got OH, it can't be an alkene. The fact that this one has got Cl, it means that it's not an alkene. So the answer is either B or C. Now, how do we know? We test them using this formula, Cn, okay, H, and 2N. So we test them. So the first one has got a 4. So if we say C4, okay, then H there, a 2, where there is N, we put a 4. So this one is going to be C4H8, which conforms to this one. So this one is correct. This one, because if we put a 4, it will be 8, then plus the 2 is going to give us a 10. So this will turn into an alkane, which has got a formula similar to this one here. All right, question 20. So now, organic chemistry, as I wrap up section A, organic chemistry, about three questions, 17, 18, 19, 20 or so, they are about organic chemistry. So you have no choice but to know organic chemistry. Okay, so study the organic structures below. So these are the structures that we've been given here. Then the question says, which one of the above structures are what? Are isomers. Okay, now isomers are isomers, these are organic compounds that have the same molecular formula but different structural formula. So same molecular formula but different structural formulas. Okay, so what we can do here, let's convert these into molecular formula. So we just say 1, 2, 3, 4. So this is C, 4. Then you have H. We see what we come up with. So we have H, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9. So we're just going to write C9. Then it has an OH at the end. So that is the molecular formula there. We do the same to this one. We have 1, 2, 3, 4. So this is 4. So we also have C4. Then we count. This is 1, 2, 3, 4, 5, 6, 7, 8. So this is H8. And it has a double bond. Then we do the same to this one. This is 1, 2, 3, 4. So that is also C4, then H. Okay, so C4H, then we count 1, 2, 3, 4, 5, 6, 7, 8. So this is the 8 here. Then we do the same to this one. We have 1, 2, 3, 4, 5. So this is C5, then H. Okay, so C5, then H. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 10. So now let's look at two formulas that are the same. So we've got this is 2 here, this one, and this one here. So this is the 2 and the 3. Okay, so giving us the answer as B. So that marks the end of section A. All right. Let's see if we can also go to section B. Okay, so section B, it says answer all questions. Write your answers in the spaces provided on the question paper. Read very carefully the instructions on the answer sheet. Now, instructions always part of the exam. So let's go. The first one says, describe, and you answer everything within the provided spaces. So describe the types of movement of particles in what? Number one, solids. So here the answer, please pay attention to what I'll be saying. I'll be doing less of the writing. Okay, I'll only write when it's necessary to write. So follow me as I explain through. So the short answer to write here is that solids vibrate about their fixed positions. Then liquids vibrate by moving over short distances. Those are the answers. Solids vibrate about their fixed positions. Liquids vibrate by moving over short distances. So chemistry has been found to improve the livelihood of mankind. State any two benefits of chemistry to mankind. Okay, because of chemistry, we are able to make medicinal drugs which improve our health. Because of chemistry, we are able to purify water. So because of chemistry, we are able also to make cosmetics, etc., etc. We go to B2. The diagram below shows one of the laboratory apparatus. Now, the name of this apparatus is called a separating funnel. So this guy is called a separating what? Funnel. So now, how does a separating funnel work? It's very simple. A separating funnel is used to separate two immiscible liquids. Okay, two immiscible liquids. For example, you can have a mixture of cooking oil and water that can be separated by a separating funnel. So this thing, it has a tap here, and once you mix, the one that is denser, that is denser will go at the bottom, then the one which is lighter will be at the top. Then you can easily open the tap and one will go out, leaving the other one. So there's a clear separation that is formed. Okay, so now we are saying, state the use of the apparatus shown below. Like we have said, it is used to separate immiscible liquids. Examples here we have cooking oil and water. Proceed. In chemistry, substances are classified as compounds or elements. Okay, so in chemistry, those are the separations there. So we should be able to remember that an element is a pure substance which cannot be split into two or more simpler substances. Okay, once we know the definition, then we can tell the differences. So here, the two things that you are interested in is distinguish, they're talking about an element. So an element is a pure substance that cannot be split into two or more substances. Then a compound, on the other hand, is a compound is a mixture of two or more elements which are chemically combined. So compound is a mixture of two or more elements that are chemically combined. Okay. So the difference here is that an element cannot be split into two or more substances, whereas a compound can be split into two or more compounds by chemical means. The table below shows the chemical formulas for substances. So these are the substances that we have. Then from the table, classify the substances into elements and what? Compounds. Now, when you look at oxygen, oxygen is just a diatomic element. So this one is an element. Then hydrogen is also a diatomic element. Then this is ammonia here. In ammonia, we have nitrogen and hydrogen. So it's a mixture, this one, which has just been chemically combined. So this one is a compound. Okay, so that one is a compound. And this one also we have sulfur and oxygen, meaning it is also a compound. We go to B4. Study the reaction scheme below. So we have dilute sulfuric acid and we have magnesium metal. So now here you can see this is acid. So we're talking about acid plus metal here. Okay, this is magnesium metal. So what we expect is that we are going to have a salt plus hydrogen gas. That is the general rule. Okay, so here they are now, you can just write an equation and it will answer all your problems. So here we have magnesium metal. So this one will just be Mg with the state symbol S reacting with reacting with sulfuric acid, which is H2SO4, and this one should be able to give us okay, Mg. So Mg has got 2, so it will just be MgSO4, and this is aqueous plus so always putting solid, so this is aqueous here, aqueous AQ. Okay, then even this one will also be aqueous. We put in smaller brackets AQ. Then we have our hydrogen gas. So this is hydrogen gas here. You have a G. Okay, hydrogen gas. Now you can ensure that your equation is balanced. So we have 1 there, 1 there, 2 there, 2 there, 4 there, 4. Okay, this one is balanced. Now let's answer the questions. So identify substances A and D. So as you can tell, A here, this is the magnesium sulfate. Then B, this is simply hydrogen gas. So this is our B. Okay, identified. Then magnesium sulfate is an ionic compound. Write the chemical formula of all the ions that form magnesium sulfate. So here we are just writing the ions. So now the ions is where you split this guy. So when you split this guy, you are going to have the following ions. You are going to have Mg2 plus and okay, and SO4, then 2 negative. So these are the ions that you're going to have. Remember, when you are writing a formula, we do write like Mg with a 2 here, then the sulfate also with a balance of 2 there. Then you interchange these 2. So when you interchange these 2, since they have 2, 2 is going to cancel. That is how you come up with the Mg, SO, and the 4. So that is where all this is coming from. Then write a balanced chemical equation showing state symbols for the reaction between magnesium and dilute sulfuric acid. This is the one. All of it here is what you're supposed to write here. Then name the acid that is so this is name the acid that is found in milk. So the name of the acid is called lactic acid. So the name is lactic acid. So we have lactic acid. Okay, so this is lactic acid. All right, we continue. We go to B. Okay, that was B4. We'll check out B5 and 6 later on. Go to B7. So B7, the question reads, Group 8 elements of the periodic table are also called Group 0. Explain why Group 8 elements of the periodic table are also referred to as Group 0. So the answer is very simple. They have a valency of 0, meaning they have no valence. What common name is given to Group 4 elements of the periodic table? So these guys are known as noble gases. Okay, they are called noble gases. Group 4 elements of the periodic table have practical use in everyday life. Group 4 elements of the periodic table have practical use in life. Give one use of argon. So this one is used in a light bulb. Okay, it's used in a light bulb. So in argon, you find in a bulb you find argon. Okay, we go to neon. Neon is used in advertising signs. We see when we are moving around on the road, you see some advertising signs and all that. So that is the use of what? Neon. Okay, we go to B8. One of the ores from which zinc is extracted is zinc blende. What is the chemical name of zinc blende? So the chemical name for zinc blende is known as zinc sulfide. So you write it in words and you put the formula in brackets. So it's zinc sulfide. Okay, so that one is known as zinc sulfide. Okay, now zinc blende is roasted in air, producing zinc oxide and a gas that should not be allowed to escape into the atmosphere. Name the gas produced. So the gas produced is simply sulfur dioxide. Okay, why should you not allow the gas to escape into the atmosphere? So this one might cause acidic rain. Sulfur dioxide might cause acidic rain. The zinc oxide produced is reduced to zinc metal at a high temperature by a reducing agent. Okay, name the reducing agent and construct the wage equation for the reaction. So the reducing agent is actually carbon monoxide, and the reaction is written as follows. So we are going to write zinc oxide, definitely, which is a solid. This one will be reduced by the reducing agent, which is CO, and this one we know it's a gas. Okay, so since it's a reduction, what we are going to have here is we are going to have zinc as a solid. Okay, so zinc will be reduced as a solid, then carbon dioxide will be given out. Okay, so carbon dioxide is this one here. So that is our balanced chemical equation. Now, zinc is used in making roofing sheets. Okay, so give one use of zinc. This one is used in making roofing sheets. Okay, so B9, we try to explain this one as well. Okay, so ethene C2H4 is an unsaturated hydrocarbon. It is manufactured from petroleum as shown in the flow chart. So we have petroleum uh, going to kerosene, kerosene going to ethene, ethene going to polyethylene. So we can simply identify these processes. So when petroleum is crude oil, actually it undergoes fractional distillation. So fractional distillation, it will separate into various components. One of them is the kerosene. Then this kerosene here is a large alkane. So large alkanes can be broken down by a process called the catalytic cracking. So when you crack large alkanes, you produce alkenes, for example, ethene here. So ethenes also can be polymerized under addition polymerization to form polyethene. So this was what was happening in here. So name the two processes Y and Z. So Y and Z, this is catalytic cracking, and this one is the addition polymerization. Okay, so the question reads, describe either process X or Z, include necessary conditions for any reactions. So you can, if you are explaining, if you are describing process Y, for instance, you are just going to explain to say process X is fractional distillation. So petroleum is a mixture of long chain hydrocarbons and some elements like sulfur and nitrogen. So petroleum is heated. So petroleum is heated. Okay, it is heated to begin to separate according to their boiling point. Those lighter ones are eluted first due to lower boiling point. Then for Z here, we can also describe addition polymerization. Okay, so we go to C. Ethene can undergo hydrogenation process with hydrogen. Write the reaction equation using displayed structures. Okay, let me see if I can squeeze it somewhere here. So using displayed structures, what you're going to have is, this one is ethene, that one. Hydrogenation simply means addition of what? Hydrogen. So this one is going to be the hydrogen, like that. Then this one like this. Also there we have this one like this. Also here we have the same arrangement. So reacting with what? With the hydrogen. Hydrogen is diatomic, so we write H and H. Then this one definitely it will be transformed into such an arrangement. So see here we have the H there. Then we also have the H at the bottom. Then this should connect to the C. We have the H here, and we also have the H there. Then from there, we can have another H. So this is the displayed structure. And here we can use a nickel catalyst. Okay, so we use a nickel catalyst. All right, ladies and gentlemen, we'll end here for now, and we'll continue with section C in the next video. Thank you so much. If you've been watching us for the first time, do not forget to subscribe and inform others about our learning room. Thank you and bye bye.